Okay, so we have talked about how to find critical numbers. We've said that if there are any maxes and mins in the function, they have to be one of the critical numbers. Because remember the golden retriever dog thing? All the maxes and mins have to be critical numbers, but not all the critical numbers have to be maxes and mins. We did that. What we haven't done, though, is once we find the critical numbers, we haven't talked about how to determine if it's a max or min. Obviously, you could graph the function on your calculator and look at the picture, but we want to be able to do it algebraically. Okay, and that's where the idea of the first derivative test comes in. And before we get to the first derivative test, we need to talk a little bit about increasing and decreasing. It's a fairly simplistic approach, but we're still going to look at the calculus speak so you can understand what they're saying. As I mentioned, we'll talk about increasing and decreasing. We'll then talk about the first derivative test, and then sometime today, please, try to compliment two strangers. 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 So you're saying stranger danger overrules complimenting a stranger?
I think it's okay if
Are you saying that you're afraid of all strangers?
I think it would be safe to compliment them from a distance. Safe distance.
You're not going to come up and give somebody a hug, just, passing something in a party. Okay. Anyways, so increasing and decreasing. Yeah. Here's the calculus speed. We've got 2 points, x1 and y1, and we start by establishing that x1 is less than x2, which means visually x1 is on the left of x2. Okay. We plug those into the function, whatever the function is, and we get f of x1 and f of x2. Those are the y values. The function is increasing if f of x2 is greater than f of x1. Okay, so it's higher. It's going to go up. It's decreasing if the opposite is true. You still have x on the left. You have x1 on the left, x2 on the right. And if f of x1 is higher than f of x2, then the function is decreasing. It's real simple. If the function is going up, it's increasing. If the function is going down, it's decreasing. What we're going to focus on today is what happens when it changes. What happens when the function changes from increasing to decreasing or decreasing to increasing. That's when the fun stuff happens. What does happen? What happens when the function is increasing? Let's say, for instance, we have an upside down parabola.
Oh, we have
The function is increasing and then all of a sudden it starts decreasing.
max or min.
Well, which one in that case?
Oh, if it's increasing, it's max.
Max, correct. And if you have a plain old parabola that's going down and then turns and starts going up, you're going to have a min. And that's the gist of what we're going to do today. Okay, here's the fancy definition. If f prime of x is greater than 0, then it's increasing. If f prime of x is less than 0, then it's decreasing. If f prime of x is equal to 0, then it's constant, neither increasing nor decreasing. Again, if you think about that logically, if the slope of the tangent line is positive, it's rising, which would be increasing. If the slope of the tangent line is negative, it's decreasing or going down. And everything is moving left to right like you would along a number line. And all this theoretical stuff is great, but when we get into it, you'll see it's a pretty easy process to work with. I got a whole bunch of examples for you to see that. Thank you. You're welcome. Very kind of you. Thank you. You're welcome. See that as a compliment. If we were strangers, then I would satisfy one of the two. But I'm not sure if you break that stranger. Because I'm not in danger.
Sure.
Today.
It is always a risk, though.
It is a risk.
Yeah.
Of course, you're, what, 18?
Yeah.
Yeah, so.
Sounds like parental consent.
Well, and you also have to consider that you might be the danger for the other party.
That's true.
I wouldn't go like hang out on the playground and start complimenting kids.
Don't say that you have candy.
Yeah, that's a good point. Or a van with no windows.
White van.
A white van, correct.
I almost bought turquoise.
My mom was at one. I said it was a guy.
Okay, here we go. Let's find out where this function is increasing and decreasing. First step, find the critical numbers. Go ahead, I'll wait.
real, I don't know, it wasn't there before.
What is that? It's a fake bug?
It's not real. Like, who is this? It scared me. Yeah, I heard something, so I looked down and it was there.
I'll save it for later.
Oh, that's creepy.
Save it for a rainy
Drop it
day.
on somebody's desk while they're taking the test.
Oh, no, put it on the
Or while they're taking a test, you like throw it across into something.
Funny kind of derivatives.
That's
So
so
bad.
Oh, that'd be good. So that pops out in the corner.
What's?
What do you got?
I'm not done yet.
Okay. Un momento, por favor.
See.
Gracias.
Would you want us to do the whole thing or just find the critical numbers?
Let's just start by finding the critical numbers, then we'll do the rest together.
Got it. Yeah.
Okay, we got a couple people with critical numbers. What are they, Specky?
0 and 1.
0 and 1, everybody else?
Yeah,
Are you agreeing or do you have a question, Adam?
Find the derivatives so that equal to 0.
Awesome.
I have to point for Nicole.
Yep. Okay. So finding critical numbers again from the last 2 days, take the derivative, set it equal to 0. Thank you, Nicole. I did that. Boom, boom, boom. There you go, 0 and 1. We're all in agreement? Excellent. Now we're going to take it to the next step. And the next step is determining where the function is increasing and decreasing. There's a very specific way to do that. We're going to use something called the first derivative number line. There it is. This marking is very important. Don't just draw a line, put f prime next to it, or g prime or h prime, whatever function you're dealing with. That's going to help you do a couple things. Number one, it satisfies the condition for the first derivative test, but number two, it will act as a reminder of where you're supposed to put points or numbers, and that'll make sense in a second. Okay, so draw the number line first. Then graph the numbers on the number line. I'm not trying to be funny with the following statement. Please list the numbers in numerical order. Okay, I had obviously 0 and 1. You know that 1 is to the right of it. But when you get 3 or 4 different numbers and they might be something bizarre like the square root of 3 halves, make sure you're putting it in the right spot. Two critical numbers divide the number line into 3 regions. We need to test each one of those regions. So, what number would you like to test to the left of 0?
-1.
-1 is a good choice. Where are you going to put that -1? That's why that's there. You put -1 into f prime. And when you put -1 into f prime, what do you get? Now, I don't care about the number. I just care about the sign. Is it positive or is it negative?
Positive.
Positive. Are we all in agreement? Good. And I'll show you how to mark that in a second. Be patient. Pick a number between 0 and 1. 1/2. You plug 1/2 into the derivative, and what do you get? Positive or negative? Are you asking? Negative? It is negative. And then a number greater than 1. 2. There are an infinite number of possibilities to the right of 1. Sometimes it might be in your benefit to choose a really bizarre number like 1,000. It's entirely up to you. It doesn't matter. And again, all we care about is the sign. When you do that, this is how you mark up your number line. Below the number line is the sign. It was positive, it was negative, and it was positive. And then those arrows up on top indicate increasing or decreasing. You don't have to show the work for the testing. I'm assuming you know how to plug numbers into a function. Common mistake that people make. You take a problem like this, you test the first region to the left, and you get positive, so then you think it's going to go positive, negative, positive all the way down. It doesn't always do that. You need to test each and every region. Excuse me. Now, looking at that graph, the reason I have you put the arrows up above is because it kind of gives you an idea of what happens in the graph. So what happens at 0? It's a maximum, correct. Goes up, then down. What happens at 1? It's a minimum. Okay. And that's it. That's how we determine. This problem is only increasing and decreasing. I should have read the directions. Where is it increasing? How would you express that answer? Yep, negative infinity to 0 and 1 to infinity. Would you include 0 and 1?
No.
Why not?
Because it's not increasing.
It's level. Good. You would get some calculus teachers that would argue with you and say it has to be included. I like the parenthesis, not the bracket. Yo.
So when you were writing like your answer, would you say, increasing and then put it, or?
Yeah.
Okay.
And then decreasing from 0 to 1. Okay? First derivative test. Now we take it a step further. We take what we did already with increasing, we take the first derivative number line, and we use that to get to the first derivative test. The first derivative test is a test that you use to check to see if critical numbers are maxima or minima. You've already done that. Okay, we're just going to do it again. So this is the graph we just did, and as you can see, it fits exactly what we thought. It's increasing up to the point of 0, then it goes down, so 0 is a max. By the way, these are relative max and mins, not absolutes. And then it decreases until it hits 1, 1's a minimum, and then goes back up and increases. Okay. So we need a way to express that, and that leads us to the first derivative test. There it is. There are 3 parts. 1 and 2 are pretty straightforward. We talked about already. We will talk about 3 after you're done writing. Notice it says, like, for instance, in number 1, f prime goes from positive to negative. It doesn't say from increasing to decreasing. Use positive and negative. Can I talk while you're writing? Number 3 is the possibility of not having any extrema. It doesn't necessarily have to have a max or a min. Gesundheit. And again, as a refresher, notice the first line says critical numbers are where the derivative is equal to 0 and where it's undefined. Part 3 takes into account the possibility where it's neither a max nor a min. So it's always increasing or always decreasing.
Does it matter where it says f prime and then f prime of x? Like, is there a difference?
No. I was probably just too lazy to type the parentheses x parentheses. It's the same thing. Okay, we good? All right, let's do some examples. Yeah, so, you know, that's pretty logical. If it goes up then comes down, you got a max. If it goes down then comes up, you got a min. All right, so now we're going to take take all of that and put it together in one problem. We want to find the relative extrema of the function. The process goes like this. You find the critical numbers, you slap the critical numbers on a number line, you test regions, you answer the question. Okay, so start by finding the critical numbers. That's how it's going to be. Got them? This factors. Set it equal to 0. Let's see, 3x plus 5 minus 1. Okay, so x is equal to negative 5 thirds and
Wait, no, it
1.
should be the other way.
No.
That's right.
It's calculator says something else.
Question in the back.
What's the back of your shirt?
I was thinking that too.
Yeah, sure.
Alright, can I see it?
I was trying to figure it out.
Retweet
I'll show you later.
minus sine t.
It's better to show you than to tell you.
Cool. Thank you.
Okay, we got the critical numbers. Let's see, critical numbers. Put them on a number line. What number line is this? F prime number line, good. Negative 5 thirds is on the left of 1. Jackie, what number would you like to test to the left of negative 5 thirds? Negative 2, you want to get real close there? Or you want to do negative a million or? All right, we'll do negative 2.
Negative bill.
She chose negative 2. You can go all the way back up to the derivative here before it's factored. It might be easier to plug it in here, however. If I plug negative 2 into this first parentheses, I will get a negative answer. You with me? Put a negative answer or negative number into this, I will get a negative answer. And a negative times a negative is positive. It's increasing in that interval. Oh, Jackie, what would be a good number to pick between negative 5 thirds and 1?
0.
Hot diggity. If I put 0 in there, I get 5 times negative 1, which is negative, decreasing. And last but not least, what number would you like to pick to the right of 1? 2. Positive times a positive is positive. Psh. Good. So what does that tell us? Adam, question?
If you plug it into the derivative of x, would it be negative?
No. That's 12 minus 9 is positive 3. What does that tell us about negative 5 thirds, Jackie?
It's maximum
Why?
because it's increasing and decreasing.
Good. And what about 1?
It's a minimum.
Because?
It's decreasing and increasing.
Good. Now, there's a very specific way to express that. The College Board is very, in fact, I have all this written down, so give me a second here. Yes, I did this. No, okay, yeah, yep, great, did that. There's critical numbers, okay, beautiful, did that. Oh, there's matches, okay. So, as I said, College Board is big on math people writing sentences. So there's a very specific way that they would like you to express the fact that negative 5 thirds is a maximum and 1 is a minimum, and it goes something like this. 2 chunks of information you need to convey. Actually, 3 chunks. Is it a max or a min? Where does it happen? And why does it happen that way? So a relative min occurs at x equals 1 because f prime changes from negative to positive.
So that's like what you had to put on, like.
Correct. Yep. And this is how you're answering the question. The common mistake that people make is they think that the first derivative number line does the same thing. They won't accept that as a reason or a proof. Or a justification, that's another big word they like, is justify. Justify why negative 1 is a relative min. Well, this is your justification, the sentence. And then the other one would be that. A relative max occurs when x equals negative 5 thirds because f prime changes from positive to negative. And yes, I want you to use those sentences all the time.
We use them on our test.
Am I making an untrue statement when I say this doesn't seem that bad?
No.
Good. Okay, you got the sentences down?
Yeah.
Let's try another one. You do this one on your own.
Wait, what's the difference between this and the other thing?
Nothing. The other thing, we found critical numbers and then just figured out where the interval, where the graph was increasing and decreasing. When we find the extrema, we're looking for the max and the mins.
Oh, so it's like the same.
It's just a building process, yeah.
Well, she's not.
As a helpful hint, I would not do that as a product rule. distribute. It's easier. What's x to the 1/3 times x?
X to the 4/3.
Good. Just checking. Unfortunately, one of the problems with these type of questions is that there's a lot of stumbling blocks. What you have to figure out is how to get past those. Like for instance, if you're having trouble taking the derivative, that's your first problem. Second problem is having trouble figuring out where it's equal to 0. In other words, taking a derivative, setting equal 0, finding those points is the second stumbling block. Third problem, which shouldn't seem like a problem, but it happens all the time, is being able to plug numbers into the derivative to test whether it's positive or negative. About the only time people don't have trouble is when they have all the information and they have to summarize. Anybody have critical numbers yet? Okay. So our first stumbling block is taking a derivative. Let's do this together. Did everybody multiply it out?
Yeah.
Okay, good. So f of x is equal to 8x to the 3rd minus x to the 4/3.
Yeah.
So f prime of x is 8/3 x to the negative 2/3 minus 4/3 x to the 1/3. How am I doing so far?
Okay.
Good. Everybody with me?
Yeah.
What do I do next?
Take out 4/3 x to the negative 2/3.
Good. Take out a 4/3 x to the negative 2/3. When I take this out of here, I'm left with 2. When I take this out of here, I'm left with x. Which is good. And like I said before, we took a difference problem and turned it into a multiplication problem, which is exactly what I want. Now the question, yes sir?
How'd you get it left with just x?
X to the 1/3 divided by x to the negative 2/3 is x to the 1/3 minus a negative 2/3, which is x to the 1. That's why we take the smaller negative exponent. This one's easy. What's x? 2. How about this guy? 0, correct. Now notice that's a negative exponent. That's actually a 0 in the denominator. That's an undefined critical number, but still a critical number. Why did I write 0 there?
You're silly.
I'm silly, yeah. Yeah, I was thinking ahead. Okay, now what? Number line. What kind of number line is this? F prime. 0 is to the left of 2. Go ahead and test your region, see what you get. Don't assume that it alternates. Before you start plugging and chugging, what can you tell me about x being raised to the 2/3 power?
Wait, what? 2 cubic.
What can you tell me about x raised to the 2/3 power?
2 cubic.
It's always positive. because you're gonna end up squaring it, and the squaring will make it positive. So you don't even need to plug in there, you just need to plug into the other one and multiply the signs together. So what's the first region, positive or negative?
Positive.
Positive, why? Who said, is that you, Abby?
Yeah.
What number did you put in?
-1.
2 minus -1 is positive, positive times a positive is positive. Well done. What'd you pick in here?
1.
1, positive or negative?
Positive. Question 2 minus 1 times 1 or 1.3.
And in here?
Negative.
Okay. What does that tell you about 0?
It's a pole.
Oh, it's a.
Absolutely nothing. We know nothing about it.
Oh.
Well, what we do know, I should say, not absolutely nothing. We know it's not a max and it's not a min. It could be just a weird old funky point. It could just be a normal, who knows? What do we know about 2?
There's a relative min because at x equals 2, f of prime changes from positive to negative. I mean
Well,
max.
well said. A relative max occurs at x equals 2 because f prime changes from positive to negative. Let's not even do that. Positive to negative. Good. Okay, that's it. Taking a derivative, finding critical numbers, slap them on a number line, test region, you're good to go. Any questions on the process? No? Beautiful. Get rid of that, come back here, and there we go, day 41. So let me stop this recording.
Oh, I get the units.
That's actually